Horsetooth Reservoir. In the case that long-term effects are found from firefighting foams, we will try to implement a strategy, for example, reverse osmosis. Some of the environmental impacts include foaming, oxygen demand, aquatic toxicity, and biodegradability. And though firefighting foams aren't regulated explicitly, many of the ingredients in firefighting foams are regulated.
So here's our decision matrix. Our most important design parameter is effectiveness to deal with changing water quality parameters. And we also want to make sure it's very compatible with the current system because space is limited. Keeping down our capital costs and our operation and maintenance costs is also very important. And then all 10% worth of our decision matrix are going to be dependability, the ease of operations, being good for the environment, and health and worker safety.
Our projected plan of action for this project to help mitigate the effects of the wildfires on our drinking water. Our first plan is to assess exactly what changes are occurring. We also have to plan for variability. We're going to have to look at current data and past data that tells us, during the year what aspects increase naturally and what we have to account for with the increase of the fire. And we're going to have to make a final decision on whether or not we could just update the current systems and change the operation of them, or if we have to actually do a full-scale infrastructure overhaul to account for these massive influxes of the contaminants we talked about.
And for our project schedule, after our proposal, for our March 14th, we'll have our written assessment report, where we will come up with ideas to deal with each of these topics. And then on April 25th, we'll have our final design presentation where we will narrow down the topics and figure out which ones fit within our decision matrix.
Here's a copy of our project budget. We expect an estimate of about $22,000 and total man-hours of 445. And any other questions can be asked at the end or found in our proposal. And one of the things that makes our team the most effective at water treatment is we all have professional experience within water treatment. Some of us do research or have held internships. But we all have a diverse background that allows us to make a unique and specific decision and design for the Fort Collins Water Treatment Facility. And to ensure quality control, we will collaboratively analyze each other's work to ensure excellence and that the best design is chosen for Fort Collins. And any questions regarding our team, fire water engineering, or forest fires in general?
Have you guys found any information on volumes of the foam used during fires?
No, we haven't.
And a lot of the firefighting foam was usually, the runoff from that was come from the Cache la Poudre River. And so that was also one of the reasons why they turned off that water system for 107 days, because it had a higher chance of being contaminated with solvents and surfactants.
Currently, there's no known amounts of firefighting foam left on the Poudre watershed, but as we kind of talked about, we're still trying to look into the long-term effects of the foam. Jenna?
I know you guys were saying you're going to assess what's happening with the area around the fire, but are you going to look into how the amounts of nitrate and all that stuff, or even the foam, is it going to affect the invertebrates of the water, which will affect fish, which will potentially affect fishing and putting out a warning to people to not eat the fish?
Yeah, we did find that, thanks for mentioning that rainbow trout actually, the firefighting foam affects them a lot, but our task is more of the inflow into the drinking water plant, and not so much as trying to remediate the area within the burn area.
But going off what you said, we did do some research on how heat and just the forest fires themselves affect the water. Typical streams that run through a burn area, they'll be on average 6 degrees Celsius higher than when they left. And if you guys remember from chemistry, the solubility of oxygen decreases as the temperature of water goes up. So the total organic carbon, or the dead matter will increase with that, and that is one thing you have to look at. But the scope of this project is more focused on the influent in the drinking water plant.
You had mentioned that you were thinking about changing the coagulant dose that was applied at the head of the treatment train. What are some of the options you guys are looking at for the switch to the coagulant?
Well, they use alum right now, and studies have shown that if you have sufficient alkalinity, a ferrous chloride coagulant would be more effective and remove total organic carbon more efficiently.
If there are no further questions, we'd like to take this time to thank the City of Fort Collins and you all for being here. We look forward to input and how we will continue the design process.